Electrostatic speakers added a whole new vibe to the home music scene. Unlike traditional box speakers, electrostatic speakers are usually tall and skinny, and instead of using an electromagnet to produce sound, they rely on conductive layers of plastic and metal. Electrostatic speakers generate rich audio in the high and mid-frequency range, but they lack the thumping bass needed for full sound reproduction. To compensate, most are now equipped with a woofer. To make the woofer, a computer-driven router cuts out cabinetry parts from veneered MDF. The router carves long grooves. They'll be used to fold it into the woofer box. It also cuts out holes for a speaker cone and hardware. A worker glues and drills screws into the bottom of the cabinetry for installing the speaker feet. He trims the excess from the edges of the cabinetry panel. He beads high-strength glue along the joints and folds the grooved panel to create the cabinet box. The glue is stronger than screws and acts as a kind of cement to hold the cabinet together. He sands the wood veneer at the joints for a seamless look. And now it's into the spray booth for the finishing touch, a dark, glossy varnish that accentuates the wood grain. Once the paint dries, a technician pads the inside with a polycotton baffle to reduce resonance. He then installs the crossover unit. It splits the audio signal to send low notes to the woofer and the rest to the electrostatic panel. Next up is the power supply and step-up transformer for boosting the amplifier signal. He attaches the assembly to the interior wall of the woofer. He now wires the speaker cone to the crossover unit. He inserts the cone in the slot machined for it, and it's a perfect fit. He boosts the bass with a built-in amplifier. He wires it to the crossover and pops it into the back of the woofer box. This woofer is now ready to be paired up with its electrostatic mate. They make the electrostatic speaker from two perforated metal panels. A technician applies a charge to them to check for thin spots. Next, she bends each one to a 30-degree curve. This will allow sound to be more widely dispersed in a room. She presses heavy-duty double-sided tape onto the edges and applies rigid plastic strips called spars crosswise. They stiffen the panels to withstand electrostatic forces. She now unfurls thin but super tough plastic and stretches it to a precise tension. This plastic is the speaker diaphragm. It's been impregnated with a conductive coating to respond to an electrical charge. She positions one of the perforated panels under the diaphragm, and with the backing of the adhesive tape removed, she jacks up the table to press the panel to the plastic. She attaches wiring that will deliver the charge to the diaphragm and make it vibrate. She applies more double-sided tape to the other side of the diaphragm and peels off the backing. Workers position the second speaker panel on the diaphragm and align its fine mesh with that of the panel below. They place the speaker sandwich in a metal capsule to vacuum press it together. Then they frame the speaker with an aluminum border and add a strut to the middle for reinforcement. It's now time for the electrostatic speaker to be joined to the woofer. The tall, slim electrostatic speaker will deliver the high and mid frequencies. The short, boxy woofer will thump out the bass. Then it's into the test booth to confirm that the speaker has the correct range. The technician runs an audio tone sweep and checks for any dropouts in the frequency. Using a special tool, he verifies that the sound waves of the speaker set are in sync, a process called phasing. He then places the speaker in a padded room to test a full range of tones. A computer analyzes the tones. Once it passes all the tests, this electrostatic speaker links up with the rest of the sound system. It's now ready for its audience.